Hello, good morning, good afternoon. It's afternoon. Coming off the other meeting here. All right, today we're going to be looking at dimensional analysis word problems. I gave you a sheet of 4 or 5 word problems I'd like to do together with you today. Follow along and submit them when you're done. I think I told you to submit them. But there are only 4 today, and I'd like to walk you through them. I will give you some more practice with this tomorrow, maybe. I don't even know what's scheduled for tomorrow. Tomorrow's May crowning, so I'm not sure what's going on. I actually have this continued tomorrow because which is probably true. I'm probably not going to get through all 4 of these today, so we will continue this and maybe give you some more problems tomorrow. All right, I think I'm set. Okay, so let's look at our first problem. This is problem 1. Let's go in. This is problem 1 from that sheet. So again, today just follow along as we do some examples. It is no different than what we've been doing, with the exception that all the information we need is now given to us in this word problem, and we just have to read carefully and pull things out. So the first thing you want to look for here is the question. Just like most word problems, you want to know the question here. What do I start with and what do I end with? No, we're doing them together. You should just follow along. If we don't finish it today, we'll finish it tomorrow. They are fairly difficult. They take a few steps, and some of the numbers might be a bit much for you. So let's just do them together as examples of things you see, and then tomorrow you'll get something that you can do on your own. Probably a little easier version of these problems. But our first problem here is actually one of my favorites. I like it because it uses unconventional units, so it's not even using metric system or US customary system really. It's using just kind of ratios that you experience in everyday life. So this does work with any type of measurement, and that's one of the reasons why I like this. The second reason I like this is because it's just kind of a fun problem to work through to me. But our problem states, because you never learned dimensional analysis, right? You're just terrible at this. You didn't pick up on it. You've been working at a fast food restaurant for the past 35 years wrapping hamburgers. There's nothing wrong with working at a fast food restaurant, by the way. If that's what your dream is, go for it. We still need people who work at fast food restaurants. They do provide a good service for us, so there's nothing wrong with that if that's really what you want to do. Each hour you wrap 184 hamburgers. You work 8 hours per day, and you work 5 days a week. You get paid every 2 weeks with a salary of $840.34. I want to know how many hamburgers you will have to wrap to make your first $1 million. So I want to know, again, this here is my question, so I'll underline it for us so we can see where it's standing out. How many hamburgers will we wrap to make our first $1 million? In other words, just to reword that a bit, see how you know what's going, picking out the context of it. I want to know how many hamburgers. So how many hamburgers equals $1 million? So I want to take money and turn it into hamburgers, because that's what it's given me. It's given me $1 million. That is my given. I want to take money and turn it into hamburgers. So how does money relate to hamburgers here? So this here is the question. So we're going to start off what we're given. We're given the $1 million because we don't know this. So let's go ahead and just set that up. We are going to have quite a bit of these here, but we are going to have 1 million on top. If you want to use 1 and just know everything is in millions, that might be helpful, but let's just do it with the actual number here. And this is dollars, so our unit here is dollars. Don't lose our dollars. And we don't have a denominator here, it's just in hundreds, or in dollars. And we want to make sure this gets to hamburgers. So however many of these things we tack on, the ending result has to be hamburgers. So with that, in fact, down here at the bottom here, hopefully you can still see down there. I don't know how low my thing goes. You can't see my actual Windows bar. But down here, I'm going to start writing ratios. I want to know my conversion ratios or my conversion factors. And I can do that if I follow my units. Because remember, our next fraction has to have dollars in it. And the dollars have to be on the bottom so things cancel out. So I want to get dollars to cancel out. So I need some kind of relationship between dollars and something else. I don't really care what it is right now. As long as it's relating dollars to something, I'm going to pull it out of my problem. So again, I'm just going to go back to read very carefully and see if I can find a conversion factor that deals with dollars. So it says, because you never learned dimensional analysis, you have been working at a fast food restaurant for the past 35 years, wrapping hamburgers. Each hour you wrap 184 hamburgers. That has nothing to do with dollars there. You work 8 hours per day, nothing to do with dollars there. You work 5 days per week, nothing to do with dollars there. You get paid every 2 weeks, nothing to do with dollars there. With a salary, ooh, here's dollars. So it is saying, I'm really looking at this sentence right here. And pulling it out of the context there, it's saying every 2 weeks I work, I get $840.34. So there's a conversion ratio right there. It's not a unit rate, but it is a ratio that'll help me convert things, and it relates dollars. So now I can take my $1 million here, I can cancel dollars out at the top, and I can turn it into weeks. Because I know how much money I make each week, or each 2 weeks in this case. In this case, 840.34 goes with dollars. So 840.34 goes on the denominator with dollars, and 2 is going to go on the top with weeks. Now, if I stop there, I would get how many weeks it takes me to get $1 million. I don't want that. I want to know hamburgers. So as of right now, my dollars are going to cancel. That's good, and I'm left with weeks. So I know my next fraction has to get rid of weeks, so weeks has to go on the bottom. And now I'm going to look for something in here that relates weeks to something else. And again, just read carefully, because you never learned dimensional analysis. You have been working at a fast food restaurant for 35 years wrapping hamburgers. Each hour you wrap 184 hamburgers. You work 8 hours per day. You work 5 days a week. There it is, right there. Boom. 5 days a week. So I know that 1 week is equal to 5 days in this case. Just be careful, because normally you might think that a week is 7 days, but if it's a working week, you're really only working 5 days out of the week. And if you're working full time, that's only actually 40 hours out of your whole week that you tend to work. So we are going to work 1 week for 5 days. Once I find that conversion ratio, I can plug it in up here. Remember, I need weeks to cancel. You need to know how to do dimensional analysis, but we can see if your way worked. Pay attention to how I'm doing it, because that's how I'd prefer you to do it. You might have done it, you might have just did it in like different steps. See if the answers are going to be the same though, and then we'll look at it. So here 1 week is 5 days, so I know 1 week goes to 5 days. And now I know my weeks are going to cancel, and I'm left with days. Still not hamburgers though. So I know I need another conversion ratio that gets rid of days, and days has to be on the bottom, so it cancels out there. So again, reading through it, you work 8 hours per day. So there's this conversion ratio here. 8 hours per day, that is 8 hours equals 1 day. So 8 hours per day. So I know 1 day is 8 hours. Hours is still not hamburgers, so I am going to change that and get this to hours. Yeah, you can do these in different steps. Like you can just take, hey, I'm going to do this part first, then I'm going to do this part, or so on. Take the answer from that and do it to there. I'm setting it up all in one equation to get it all done in one step. So it is possible to do it differently. But you're pretty much just multiplying by conversion ratios. That's really what it is. I need hours to cancel now, so I need something about hours, and it says that each hour I wrap 184 hamburgers. So I know 1 hour equals 184 hamburgers, which is what I want. I want my units to be in hamburgers. So here, this will be hamburgers. I'm going to abbreviate HB because I'll use capitals. HB. And I know 1 hour is 184 hamburgers. Now when I solve this, I'm going to get my answer. And it's going to be in hamburgers, just double checking my units. Hours will cancel. It's like days are going to cancel, weeks are going to cancel, dollars is going to cancel. So now I'll turn $1 million into hamburgers. So I'm going to go ahead and multiply my numerators. Feel free to use a calculator for that. Hopefully my calculator is even big enough for this one. I don't remember if it is or not. Times 2 times 5 times 8 times 184. It's going to give it to me in scientific notation, which is fine with me. Hopefully divided by 840.34. And it's going to give me, I didn't do it in steps, I just did everything together. I did everything together. I divided it. Let me pull it apart. 840.34, sorry. That's going to be on the bottom because 1 times 1 times 1 times 1 gives you 8430.30. And then let me do that again, which I'm going to get it in scientific notation, and I'll just convert it. 3 times 2 times 5 times 8 times 184. And this gives me 1.472 times 10 to the 10th in my calculator. If you did this in a calculator, your calculator might have said it's 1.72 EE10. Sometimes it reads that way. But this number is just moving this decimal point in that direction 10 times. So I get 1472, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 zeros. So this number up here is 1472, 1, 2, 3, 1, 2, 3, 4, 3, 1, 2, 3, 4. That big number, but then you divide it out anyways. Divided by, what is that? 840.34. And you're going to get this to be equal to 17516,719.42, and that's hamburgers. I'll just say HB, hamburgers. So did you get something like that? One, two, three, four, 1, 2. Yeah, Eli, that's your numerator. You need to then divide that by your denominator, which is the 840.34. Yeah, that's all I did. As I multiplied the numerator, I did 1,000 times 2 times 5 times 8 times 184, and it gave me this number. Then I multiplied my denominator. 1 times 840.34 times 1 times 1 times 1 gave me this number. And then I divided the two. We're just getting big numbers today. So you should be getting this, if you can still see it all on my screen. 17516,719. Yeah, Lyra, that'll work. You can round it. Did you divide them? The 35 is actually a red herring. You don't need it. 35. It doesn't matter how many. I mean, that's not what the question's asking. You can sit there and calculate, hey, how many hamburgers do I make in 35 years of working here? You can figure that out through all this information, but that's not what it asks. I mean, you can still, it's still the same way. I mean, you can still do it dimensional analysis wise. You just got to turn it all into years, which you have to assume some information. Like you're going to assume that you're going to be working all 52 weeks probably, or you're going to assume you're working, yeah, probably all 52 weeks out of the year, which you probably aren't. You're probably going to have major holidays off and things like that. But just watch what it's asking. But you should be getting that. Yeah, I'm not sure what you did, Eli. Uh, my concern was you got the numerator right. Did you divide by the denominator? Did you type that in the calculator and divide by 840.34? Or did you multiply it because you seem to get really big? Of course mine's bigger, isn't it? Now yours is bigger. Because I mean you got this number. That's your numerator. You're going to take that and divide it by your denominator, which is 840.34. So I would double check that. Again, your final answer is your 17,516,719.42. I mean, if you want to round it, you can round it. You're not going to make 0.42 of a hamburger, but technically, once you make your 0.42 of it, you get your money for it. It's just that the accounting firm pays you every 2 weeks and not in fractions. Any other questions about it? I mean, you saw it was the same thing. You started what we started with, and we just had to pull out our conversion ratios from the actual table here, or problem, and multiplied it out. So it is kind of a interesting way of looking at things, but that's one way of doing it. Let me hide all that, and let's bring up the next problem. I gotta copy it over. Yeah, it's how to make your first million though. It's telling you it's how the world will. Okay, maybe I worded it bad. Yeah, I don't know why you're dividing by 140.38. You should be dividing by 840.38 because that's your denominator. I don't know if that was just you not typing it in right or what. But your denominator here, Eli, is 840. So double check. Yeah, that's the correct answer. There you go. So just watch your, I mean, the multiplication on the denominator was the easy part, but watch it. Don't forget that there is a number down there. Don't forget you still have to deal with it. And you just divide it out at the end. Alright, let's go to problem number 2. This one's not too bad. The first problem was probably the longest one on here, just so you know. So if you felt like that took a lot of space, the other ones aren't going to take as much space. But So it says each dimensional analysis problem has taken you 1.5 minutes to complete. How many dimensional analysis problems can you complete in 6 weeks of math class if 200 minutes is a week? So I will give you a chance to see if you can set some things up, give you a couple minutes to look at it. I'm going to go ahead and pull out the conversion ratios in here that we know and pull out the information, but go ahead and give the next 2 minutes, take a shot at it and see if you can set it up. Again, I'm more concerned about you setting it up than getting the answer right now, but we will do both. So see if you can set it up and get the answer. Each dimensional analysis problem has taken you 1.5 minutes to complete. So I know it takes 1.5 minutes is equal to one problem. How many dimensional analysis problems can you complete in 6 weeks? So I want to know 6 weeks equals how many problems? That's the question. And it also tells me that there are 200 minutes equals 1 week. And that should be enough steps. If we start with weeks, we can take weeks to minutes, and we can take minutes to problems. So that should be enough for you to start off. Give it a shot, see if you can set it up, see if you can get an answer. And in a couple minutes here, I'll start. Hopefully everybody's been able to set up the first ratio. Hopefully, if you got your first one set up, you know weeks has to go here. If you know weeks are here, looking over here, you can take it to minutes. So we can put minutes on top. So 1 week is 200 minutes. And then you need to get rid of minutes because it's not problems yet. So minutes has to go here. Looking over here, you should know that 1.5 minutes is one problem. One problem. Weeks are going to cancel. Minutes are going to cancel. And you're left with problems. So go ahead, multiply your numerator. 6 times 2 is 12. Sorry, 6 times 200 is 1200. Times 1 is 1200. 1 times 1 times 1.5 is 1.5. Your units here are problems. You'll note you have no units on the denominator and you have no units on the numerator with the exception of problem. So this will tell you problems. And then you go ahead and reduce this fraction or divide it out, whichever you're more comfortable with. So 1200 divided by 1.5 is going to give us 800 problems. So hopefully you got something around there. If you have any questions on that, didn't understand where anything came from, go ahead and ask. Good job, Catherine. Don't forget units on things, though. Dimensional analysis is all about the units. Follow those units. Why do you have 1 week? Did I read that wrong? I have 1 week here because I know 200 minutes is 1 week. 200 minutes equals a week or 1 week. So this here is the conversion ratio of that, which comes from that. So 200 minutes equals a week, or 1 week. And therefore 200 minutes equals 1 week. 1 week is 200 minutes. Remember, the conversion ratios have to equal 1, but with different units. So it's telling you this is equal, right? 200 minutes is the same thing as 1 week, according to math class minutes, right? You don't spend every waking second in math class, right? You spend 40 minutes each day for 5 days, if you want to look at it that way. Any other questions on that one? Not too bad. All right, this one here is even easier than that. We're just hiding everything today. This one is easier. It gives you the conversion ratios right out of it, or at least some of them. So it does tell you your conversion ratios right here. I should have put inches up there. I'll do it this way. This is inches. But you know 1 mile equals 5,280 feet, because it's right there. You know 1 foot equals 12 inches right there. You know 22 inches equals 1 walking pace right there. So there's your conversion ratios. So give it a shot, see what you can do. It says how many walking paces are there approximately as you walk down Main Street, which is 1/4 of a mile, or 0.25 miles. So I'll give you a minute here, see if you can figure that one out. Your given information is 0.25 miles. No denominator. You want to cancel out miles, so miles has to go there. What conversion ratio deals with miles? That one, and that turns it to feet. And there are 5,280 feet in 1 mile. You now want to get rid of miles, or sorry, feet. Miles will cancel. You want to get rid of feet. Which one deals with feet? Well, this one deals with feet, but it'll take you back to miles, so don't use that again. This one here. So 1 foot is 12 inches. Now you're getting rid of feet. You want to get rid of inches next, and you know 22 inches is 1. And I'm abbreviating walking pace as WP because I'm running out of room. Actually, we're going to grab all of that and move it down here so I have room to write the answer. So this is going to equal a fraction. Again, multiply your numerators, multiply your denominators. 1 times 1 times 1 times 22 is 22. So your denominator is 22. Those inches are canceling, you'll note there. So there's no unit in my denominator. My numerator is 0.25 times 520, or 5,280 times 12 times 1. So 0.25 times 5,280 times 12 gives you 15,840. So this is 15,840 walk divided by 22 walking paces. And then you got to deal with that fraction. So I'm just going to come down here and divided by 22 equals 720 walking paces. Walking paces. Questions on that one? Anyone not know where any numbers come from? Not know why I did something? Some kind of notation that's there? Did you lose your decimal point? No. I don't want to do it. Where'd you get that huge number? You're doing 0.25 for the miles times 5,280 for that one times 12, and then this one's just 1, so times 1. Your number is way too huge. 5280 times 12. And it wasn't the decimal point. Good, Eli. Good, good. So then just divide that out, and you should be getting your 720. Good job, Catherine, and good job, Evie. All right, our next one, we're just hiding all of this, is dealing with scientific notation. So, can I get, it might not like it when I copied and pasted that. Yeah, it did not like my exponents. So let's clean that up a bit. This number here is actually 1.3 times 10 to the 15th. This number here is actually 1.2 times 10 to the 9th. And just getting your exponents. I'm going to tell you not to worry about your exponents, just don't solve for them, leave them there. They make life easier for you, believe it or not. See if you can set it up. Just keep in mind that this is all one number. Just treat it as one number. This is all one number, just treat it as one number. The setup for this is actually pretty simple. Just don't get confused. Like if normally you're writing a 5 for your one number, write 1.3 times 10 to the 15th for that number. It is one number. It's just written in scientific notation, which is actually going to make your life easier. You just don't know much about scientific notation right now because I didn't cover it, or if I did cover it, it was a while ago. I'm not sure if I covered it in your class though. It's all running together, especially with this weird virus thing going on and affecting everybody. So see if you can set it up. See if you can pull out your conversion ratio. It shouldn't be too hard. In this case, your conversion ratio is the end here. Chicago uses this much each day. So your conversion ratio is 1.2 times 10 to the 9th gallons is equal to 1 day. That's going to convert gallons to days. And this is the only conversion ratio there is, so there really is only two fractions here. You're starting off with 1.3 times 10 to the 15th, and that is in gallons. And technically that's in one Lake Michigan, but we don't really care. That's just how much water there is. And you should note that gallons need to cancel. So again, just follow your units and your numbers fall in play. And this would be 1.2 times 10 to the 9th gallons. And this is 1 day. Makes your multiplication easy, but your division is going to be tricky with those numbers. And I'll show you how to do that real quick. It's not really bad at all. Scientific notation actually makes it easier for you. So here, 1.3 times 10 to the 15th times 1, hopefully you realize, is just that number. And again, don't let the scientific notation confuse you. This is one number. It's being multiplied by 1. It's going to be this number, whatever it is. So it's 1.3 times 10 to the 15th. That's going to be divided by your denominator, which is 1 times this number. Again, don't let it confuse you. It's just 1 times a number, so you know how to multiply by 1. It's just going to be 1.2 times 10 to the 9th. So this here, once you reduce it, is going to equal days because gallons will cancel. So this is going to be how many days it takes to drain Lake Michigan, assuming it never rains again and Chicago doesn't change how much water it uses every time. So nothing gets recycled. We're just going to see how much water is in there, that can how long it can last. When it comes to solving this, again, scientific notation actually makes your life easier. You're actually just going to do the 1.3 divided by 1.2, and then you're going to get an answer to that, and you're going to multiply it by 10 to the 15th divided by 10 to the 9th. This you probably don't know how to do yet, but it is actually stupid easy. You just subtract your exponents and keep your base. But this you should be able to do. You should be able to do 1.3 divided by 1.2. So we're going to go ahead and do that. 1.3 divided by 1.2 is going to equal 1 point, and I'm going to round it to 1.1. (13 to the 15th). It'd be easier if I did 13 to the 15th. No. I want things in base 10. And I don't even think those are equal. 13 to the 15th is equal to... No, they're not even equal. This does not equal 13 to the 15th. Those are two different numbers. Besides, you're going to want your exponent, your base, to be 10. Right? Because you can do the number part. You can do 1.3 divided by 1.2 easily. And then when you do your exponent stuff, you don't know your rule for exponent stuff, but you're just going to subtract. When you're dividing and the bases are the same, you just subtract your exponents. So 15 minus 9 is going to give me times 10 to the whatever 15 minus 9 is, 6. So in this case, your answer is actually going to be 1.1 times 10 to the 6 days. I'll type it in your calculator. What do you get? 1.3 times, I don't know if my calculator is big enough. I don't think they're the same. You don't want my Steam messages. (1.3 times 10). Does this do? This might not do order. This does order of operations, but we're going to do it this way anyways. To the 15th. Is that what we want? That is equal to. Well, I was just going to put in scientific notation. Well, let's see what the other one does. What was that? 13 to the 15th. 13 to the 15th gives you that, which are not the same numbers, even though they're both in scientific notation. This is 1.3 times 10 to the 15th. This is 5.1 times 10 to the 16th. So they are not the same numbers, Eli. Yeah, so did I earlier. Same thing. This, if you want to solve this out, that'll be 1.1 times 10 to the 6th, which gives you what Lyra got. But honestly, You can leave things in scientific notation. You can leave your answer like that. You don't have to solve that out. If you want to do that by hand, this is just going to move your decimal point 6 places to the left, to the right here. No, because order of operations says to do exponents before multiplication. So if you were to solve this, you would be doing 10 to the 15th first, then you would be doing times 1.3. You would not be doing 1.3 times 10 and then to the 15th. So remember order of operations. You're going to do parentheses. Well, really you're going to do groupings. You're going to do groupings first, and that could be parentheses, that could be radicals. I don't know what else we've seen. Occasionally you see it as, hey, do your numerator first as opposed to then divide, like 5 plus 3 divided by 2. This says do 5 plus 3 first before you divide by 2. So you do your groupings first, then you do exponents, multiplication, and division are on the same line. Adding and subtracting are on the same line. So these ones you do left to right depending on what comes first. And I don't know if I'm missing anything. I guess technically square roots will be in here too, because they're with exponents. You don't have to understand it this year. You'll learn it next year and you'll learn it the year after that. So basically I just told you treat it like a number. In this case, subtract your this part here is the only weird part. You can treat it as 1.3. I won't give you one on the test. I wanted to give you problems that you were uncomfortable with the numbers, but you could still kind of put together and at least set up. That way you reinforce the idea that, hey, you're actually following units here as opposed to numbers. So if you were able to set it up, I mean, this part here is the biggest thing for today. If you can set it up, you showed me from yesterday and the day before and the day before that you can solve things like this. Like you understand the theory behind solving. You multiply your numerators, multiply your denominators, and then divide. You don't have to understand scientific notation today. But even if you solve this out, you'd be doing 10 to the 6th first, and that would be 1.1 times 10 to the 6th. That's 1, 2, 3, 4, 5, 6. That would be a million, right? Then 1.1 times a million is going to be 1.1 million. And that's what Lyra got. She just solved it out. But again, you can leave things in scientific notation. Any other questions about it? Because we are past 2 o'clock now, and I'd like to stop. I don't know if you guys are doing anything with May crowning tomorrow. I don't think you are. I think May crowning is really just 8th grade. So. All right, with that, I'm going to end it. I will talk to you